Thank you. So we're obviously in the room. So as we mentioned, we're building apps at scale without losing your motivation, right? Um, so just quickly a bit about me. I'm an iOS developer, touch Android and BFFs every now and then, but I mostly try to stay in the front end. I call myself a serial appist. Just careful how you pronounce that. uh, in terms of like what I do, like moonlighting wise, I've worked on like a me and you sort of app which connects with like POSs. Um, you can see some examples here. Like I made a live activity for cricket, a Sudoku solver, and also a Apple TV slash Vision OS clock. That was a fun one because I always got these ads on Facebook. I don't know if you guys ever got them where you get like the little tiny clocks which kind of spin around. It's like $2,000. Like, well, I'm not paying $2,000. I'd rather just put on Apple TV. So, so yeah, made it like a mini sort of clock like that. The idea was I would maybe even have like a party mode where you can put custom messages up or something. I don't know. The dream, and then obviously you get bored, right? Yeah. Yeah. So like I work on little things here and then. So I'm always starting a new app every now and then. Look, why we're here. So I think like programming languages, they're like Lego, right? You get the most basic pieces. You get arrays, you get all these other different things. They're all standard blocks. They all fit together in different languages, but it's up to you how you connect them to make something that works for you, right? You may use a library. Consider that maybe two Lego pieces are super glued together. That's a library. I don't know. But that's kind of how it is. Like, yeah, obviously you got everything is definitely not awesome when it's super basic, right? Um, but why we're here? The programming, like even he mentioned in the last talk as well, right? Programming is a form of art, right? Where you have to design things, architecture things in a particular way. The programming language may be your paint and how you structure it and all that stuff. Yeah, and at the end of the day, it's up to you to make your life a little bit easier. Sorry, that's also a bit of a deviled gag with Tim up there. Anywho, so let's make an app, right? That's what we're all here for. But before we get there, let's just consider something that we may want to, consider long term about the app. Do we want to make it a hybrid app? Will there be like a native component? Will there be web views? That kind of stuff. You need to store data within the app. Will it be stored in, just core data, keychain? Will you have files on the disk? Would you use like iCloud, that kind of stuff? Then you got to also consider how you get from one screen to another. How do you share data between different screens? Obviously, authentication. I don't want to read all of them, but you get the idea, right? There's a whole heap of things you got to consider. Actually, one more I want to read. Testing. That's also very important. You want to make sure your app is, when you've built something and it works, that it keeps working without you having to do it again. Yeah, and manual testing is boring. So automation, try to stick with automation. And also some nodes are considered like design patterns to use and avoid. One of the ones I like to always avoid is a singleton, but unfortunately you can't avoid a singleton. Hopefully with what I'm about to show you guys, you can kind of avoid a singleton without avoiding it, but we'll get there. Hang on. Oh, okay, there you go. Some rules. Singletons, like I was saying. Yeah, they don't work well with Swift concurrency and testing in general. Just what we'll do is we'll use what's called a managed singleton, where you have something else create your singleton, and then it kind of remains attached to the lifecycle of that other object. It's basically like a context or something you call it. MVVM, as much as SwiftUI is awesome, try to keep business logic outside of the view and observe any changes, that kind of stuff. I want to use a coordinator for handling navigation, just so that you can kind of, it's kind of a step back from SwiftUI to UIKit, where any screen can go to any screen. Um, I feel that also makes things a lot easier and a lot more powerful and that kind of stuff. Yeah, let's continue. And so, and also I want to set up some sort of dependency injection, and I want it to be configured in suites. So you get like a suite for your production app. You can have a suite for your your UAT non-production apps. Offline mocks. So let's say you're on a plane or you're somewhere where there's not a good signal. You should still be able to work on your app. And also, it's the same idea, but your SwiftUI previews, they should keep working. I mean, SwiftUI previews are really powerful, right? Like, I've worked on apps where they don't work, even though it is SwiftUI. Like, you know, something internally, maybe a symptom gets in the way or something. It just causes issues. So just something I want to try to keep working, and hopefully, it kind of works. Yeah. So the ultimate goal is to want to aim for like a top-down approach. So you as a front end, you can build what you want, back end can build what they want, and then at some point when they're ready, you can just connect it all up. You can configure your prod app dependencies and just point at the server, and it should just work. Yeah. So now let's make an app, right? So just let's start by looking at a coordinator. So this is going to be, when you create a new project, you get the hello world you get the hello world with a little logo in the middle. Just basically that, and I added one navigation using the coordinator, right? So we have the coordinator content, which is basically, it's just a wrapper around your first view, essentially. So we're gonna eventually use this inside the ad app, the main ad app. What it does is it just wraps. You can see in the middle here. Sorry, in the body. It just creates it asks to build your view, and then it kind of takes care of all the navigation because it's a navigation stack. And then if you need to ever go to a sheet or a full screen cover, you can also do that. And if you need to do anything like detents, where you have like a partial cover, you do that in your own side. This doesn't need to know about any of that. The next one is the actual coordinator. Think of it this way. Look, there's a little bit going on here, but essentially what you have present, push, pop to root. You got dismiss modal and dismiss present and content. So it's basically about if you're the child or you're not the child, that sort of thing. And then there's a build view, which you need to implement based on the previous screen, essentially. And yeah, and same thing, build modal, but it just creates like a child coordinator, so you can go from one flow to another flow. Yeah, I'll show that later, not as part of this demo, not as part of this example. And then the routes, you would have just basically, I have two routes in this screen. I have the welcome and the hello, right? And like I mentioned earlier, we'll make two changes. We'll change the main app. So we would, instead of actually creating the content view, like typically you would have content view within the window group, right? We're going to replace that with the coordinator content. And also we'll do the same thing on the SwiftUI preview, just to keep it kind of consistent. And we can put whatever you want in the body. We'll leave it with something pretty close to what Apple has by default. So yeah, let's jump in and have a quick look around. So if I just quickly switch to the coordinator app, like I said, we have those same classes that I just showed. We've got the route with the welcome and the placeholder. I think I renamed them there, but that's fine. And really, the content view, we have the standard image with the text. I added a button around it, connected back to a view model for a state object. As expected, you got the SwiftUI preview working. If I tap it, it navigates forward, just like as you'd expect with a SwiftUI preview. And yeah, so it's using a coordinator under the scene. Also, the view model is doing something special where it says welcome back when you come back. So it looks very basic, but we're going to eventually build on top of this. So if I go into the tests, they do. Oh, can I make it bigger? It's hard to see, isn't it? Let's change this. Sorry. Where is it again? There you go. Okay, yeah. So you can see in the test that we check, like, for example, that welcome back behavior. If I run the test for this, it's run as expected. Like, I mean, there's nothing too major with this one. In terms of running them in parallel or repeatedly, there's nothing that which should really call out anything, because we don't have any singletons. There's nothing unusual or any weird stuff. We just ran 100 times and didn't fail. Yeah. So let's go back to what we're having a look at here. So just have a quick summary of what we saw. We got the coordinated content. We saw the routes. We were using MVVM. We added the buttons and the navigation and that stuff. Very basic, and we obviously got the unit test, right? And the Swift UI previews are still working, which, yes, that was one of the things I wanted to kind of keep aimed at, right? Some good things. We got an easy way to go from one screen to another. We just do .push the enum and it works. We got unit tests, especially for the navigation. We got unit tests, make sure we're going to the right screen. But we're still not quite there in terms of the mocking. Like, it is a very basic app. If we did want to mock, we can't easily do that. There'll be a lot of hacky stuff. Yeah, so now let's have a look at the next sort of app. Forget about what we just spoke about with the coordinator. Let's have a look at dependency injection now. So basically what we want to do is we want to inject different behaviors into our app based on certain conditions. So like I said earlier, we'll have the prod app, we'll have the one or more non-prods. There'll be an offline mode and basically SwiftUI previews. Okay. So the way I like to do it is I like to wrap so there are libraries out there like Swin Inject, you guys may have heard of. I like to wrap the library in my own sort of wrapper. Reason being, then you can also switch it out in the future if there's any issues, that kind of stuff. It's really just calling the underlying code of the same function. So basically you do a register and a resolve. Those are the two key things in any sort of dependency management thing. And also you have the concept of, is it a singleton? Is it a weak reference which will get freed up when it's no longer needed? Or is it created every time you ask for an instance? Yeah, that's a resolver, and then we have like a config for the resolver. So I put it into an extension. So you have a config for the app. So we create an empty resolver. We give it a message bank, and we give it a message service, and the message service for the app would be the sequenced one. Let's say we're running in previews. We actually start with the for app one, and then we kind of extend on top of that. We override the message service from that one. So rather than being the sequenced message service, we now use a preview message service. I'll show you guys what the difference is there. And if we're running UI test, we do the same sort of thing, where we override the message service from the app to like a sorted message service. And also one which I haven't got on the slide is you can also have one for your unit test. You can actually override the behavior from your unit test and do additional things as well, which I think I'll show a bit later as well. Yeah. Yep. And obviously then the main change is, you just have to create some sort of resolver, which would be maintained throughout the app. And this is the part which is good or bad, I don't know what you want to call it, but you basically have to pass the resolver down to all your views as they're created. So it becomes something you have to add to most of your views. Because those views can then use the same resolver, the same configuration of sorts. Yeah, so let's have a quick look at how this would work. So I'll switch my project to the dependency injection. So I'll just quickly run the app. So the default one, it displays like the text and the color in sort of like a rainbow sort of pattern. So red, orange, yellow, green, blue, blah, 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 right? So that's the default one, right? So just keep tapping, it just does that. The message is coming from the message service, and there's also a message repo. So both of those are being injected using the dependency injection. If I open this view within the previews, which I think is this one. Ooh. Oh, I'm in the wrong project. If I open in the preview, you guys might remember from the last slide, we actually override the dependency for this one. So rather than using the rainbow one, we use this other one, which literally just has colors which cycle through, and then the SF symbol just matches the number, and I think it goes up to like 50 or something. So you can have a different behavior, different data sets for your SwiftUI preview. And the same thing, it's kind of hard to see this one, but I'll run the unit tests. I'll run the tests, which includes UI tests. You see it launches the app, and it goes through tapping it, and it does it alphabetically. And it makes sure that it cycles back as well. So we've also changed the behavior for the sake of the UI test, just so it's a bit more predictable, or whatever you really want. It's up to you. Yeah, and the key thing here is, remember, we have a singleton. If I actually run this test repeatedly 100 times, oh no, I shouldn't have done that, no, because you got the UI test. All right, let's try that again, sorry. If I only run the unit test repeatedly, because okay, I'll show you guys the way that the tests are structured. See, it already ran. It's very basic, but what the tests are doing here is, we basically, for each test, we create a new empty resolver, right? And then, or we can use the one for the app or for some other one, right? And we register our dependency, and we give it the stub message service, which belongs to the unit test target. And the cool thing here is, since we're creating it, it's still, for the sake of this test, it's still a singleton. It will get freed up when this gets freed up. And if we have tests running in parallel, then they won't actually step on each other. There won't be any clashes or anything like that. Yeah, so we've taken an approach where we've prioritized being able to run it in parallel from a testing perspective. Yeah, I think, unless I've forgotten something, I think that should be, yeah. So exactly. So those are the things I just wanted to kind of say. So yeah, we've got the different implementations of the message service depending on how it's being used. The tests run in parallel. And yeah. So now let's actually bring the dependency injection and the coordinator together and actually make something that's more fun, more of an app, right? So we're going to connect to two APIs. So there's an API called Pexels, which is basically like an image service sort of thing. And there's also, we'll use good old ChatGPT using REST APIs. Don't look at the REST API call. I use ChatGPT generate ChatGPT code. So weird. Yeah, and we'll also add some favorite functionality. So just to store the favorites on the device for yourself. Yeah, so let's have a look at that. Cool. So if I just quickly launch the app, I'll show you guys what it does. It launches, you're on the home screen. Pexels has this curated images API. So if I just go into that, you can see all the images that they've thought are nice and curated nicely. So it fetches the data, it can go into it, you view the image, and then it basically asks ChatGPT, hey, what am I looking at? And that's what it's analyzing down there. I'm curious what it's going to say about this. There you go. Close up of dense cluster of small green leaves. Right, yeah, good job. Yeah, so these are obviously the curated ones. You can search for something, like if I want to search for potato. I don't know why I did that, but yeah. You get a photo of a potato, right? You can add it to your favorites. You know, you have your favorites now. I like this potato as well. I can do yeah, let's search for some robots maybe. And we got disassembled some sort of smartphone, right? Go back. We can go back to the saved images, and our favorites are there. Relaunch the app. I'm just using user defaults. Relaunch the app. It'll still be there, right? But if you consider, so for example, the favorites, you don't want your unit tests to use your user defaults, right? You want them to be in a deterministic state every time your unit test is run. Maybe you want it to be cleared out or something like that. And then you can populate as part of your unit test setup, right? That's one thing to consider. We're making API calls. How do we manage that from a unit testing perspective? You don't want to actually make the API call. You want to check from the test that, what did it call, what data is being returned. You want to control that from the test. Yeah. So if I just quickly go into so you can see the previews. Sorry, wrong one. Just like before, we have the preview at the bottom using the coordinator content. So we brought it all together similar to before. I don't know why the images stopped loading. I was trying to figure it out and I gave up. Pretend the images are working. Woo! Yeah, look, it's behaving just as before. We can also, if I go into say the saved preview, it's not actually using the user defaults anymore. So we have no image, even though previously we did kind of save it. I added. If I go into for previews, I just commented out this block of code. If you want to, you could even pre-populate the data. So if I go back to the same preview, when the dependency is initialized, we can see that the data is injected based on how it should be pre-initialized. We can either do this in the test or as part of the dependency builder or something. It's really up to you. And and the hard stuff, that all kind of works. If I open the image, it also does that. The ChatGPT side of things, it's also mocked out. It's got the lorem ipsum text coming saying that that's what's returned. Yeah, and if I just go into, so what was the last thing? Sorry, there's one more. Oh yeah, sorry, yes, and I mentioned the search and all that stuff. So if I do any search on the search view, again, this is not going to actually make any API calls. So if I type something, I can check stuff like the buttons are working as expected. I can perform the search. It does like a mock. It's not making any API calls for us. And again, just like before, we have the tests. We can run them repeatedly. There's no UI testing, so the tests aren't gonna step on each other. It's gonna smoothly run in parallel, no issues, because every single test has its own context, sort of thing. Yeah. So yeah, whatever we created, we've basically architectured the app in a top-down sort of manner. So the app development is front of mind. We're looking after ourselves. Back-end developers, they can look after themselves. Kind of comes together at later stages, and I find it really works well. Um, Previews, SwiftUI previews and testing, they've really given a lot of focus here, right? Like we were making the most of the tools that we have. Testing is always good to have, but it's always overlooked. But at least in this, it's kind of a first-class citizen. And these patterns actually can be applied everywhere, like especially with the dependency injection. You can abstract pretty much anything. You can abstract other libraries. You can swap out functionality, and it works really well. Just try. Once you get into it, it's like crack cocaine. I mean, it's so addictive. Yeah. Just some food for thought, and some issues which I know of. Like right now, I only support like a single coordinator. You could add like for a single coordinator for a single flow, you could add generics to support multiple flows. So if you had like a registration flow, a onboarding, maybe a login flow, a main app flow, you know, you would have to you can create multiple flows sort of thing, right? My one doesn't really support that. There's another one which somebody that I worked with once, Stuart. He created this really nice medium article explaining how he's kind of gotten to where he is, and he has a nice example of a flow which can, as a coordinator that can handle multiple flows using generics. I've also purposely coupled the dependency injection and the coordinator. That's something you could probably ignore. You could probably avoid, or even I came up with this idea in the morning. But you could use the dependency injection to build a coordinator, and then that could also be used based on the flow, if as a future sort of improvement sort of thing. And yeah, look, another thing to mention is like even like I just connected to ChatGPT with basic API call, right? If you guys were next door and learning about foundation models, you could easily swap it out with a foundation model. I mean, the app doesn't need to know where the data is coming from. It's just, for us, it's just a function call, right? And like I said, any library, any native, anything can be abstracted away. Like I've used it for, the image picker. That doesn't actually work in SwiftUI previews. So I've created a SwiftUI preview wrapper which behaves exactly like the native one. So if you're doing any sort of SwiftUI preview build on an image picker, it will still come up. It will, and all that stuff. You still get the permission dialog, and all that state is managed just fine. So it just works really nicely. And it's also good for demos if you're doing demos to clients and stuff. They appreciate it. It's all in your control as well. Unlike if you had an image picker, you can only do it once a day, and you got to reset it and all that stuff. And yeah, just so much nicer. Yeah, that's the end. Any questions?
I actually have one. What prompted the coordinator pattern? Because I also hate the default Swift UI navigation system. I think it's garbage. So I was watching it going like, okay, I'm writing down little notes. So what sort of prompted that to be created?
So I think basically the idea behind the coordinator is you get the types because you're using enums to say where you want to go, and then the enums can also be they can have associated values as well, right? So if you know to go from here to here, you need this sort of data. And then that type also can map to different views. So you can even, like in my example, there's that search view and there's favorites view. They take different data. So it's a different enum, but the same view being reused, right? Just configured differently. So it just kind of abstracts that out, that kind of thing.